So this is a recording for the first part of our stats review. I try to break it into two parts so that it's not overwhelming. I mean, there's a lot to cover, and the second part is actually pretty long. So let's just do as much as I can here in this video just to get us started. Okay, so first thing we have to talk about is variables. Variables are just so again, my goal here is just to give you information so that you can evaluate things correctly when you're reading articles. I'll go into it in depth, but you just need to understand the basics. Okay. Variables are functions, and functions translate elements of a sample space into numbers. We don't really need to go into depth there, but a sample space can be anything like, say, gender or something like that, where you have different genders, and then we need to convert those to numbers. There are two categories of variables. You have discrete variables, and under discrete variables, we have nominal, ordinal, and count variables. Those all fall under this rubric called discrete. You have these notes, of course, and you'll see that I always have little footnotes with everything. I tend to love footnotes. And so here's an example of a nominal variable. In a sense, there's really no logic behind the choice of number associated with the level. There's no natural ordering or anything like that, like psychology, accounting, public health, and biology. You can assign a zero to any of them, one to any of them. You can use any number you want, actually, but I usually like to start with zero for the most popular category. And again, but it can be very arbitrary. And with ordinal variables, you have a natural ordering, but there's no consistency in the distance between any two consecutive categories. But other examples, well, here's like freshman, sophomore, junior, senior. There's natural ordering here. A place in a race would be good. Count variables, it could be anything like, and we use these a lot, especially in research related to substance use, like the number of cigarettes smoked a day, the number of alcoholic beverages one drinks in a week. Those are all things that you count, and those follow a specific type of distribution. Continuous variables, they have equal intervals, meaning the space between different levels is equal. So there's consistency there, right? Whereas with with an ordinal variable, you don't have consistency. Like in a race, first and second could be differentiated by 1 second, and second and third by 5 seconds. So there's no consistency there. You also have ratios, and not all continuous variables have an absolute zero. And if you have an absolute zero, ratios make sense. Like if you have like weight, somebody who's 100 pounds is twice that of somebody who's 50 pounds, but that's because there's an absolute zero. We use descriptive statistics to describe our data. So in all papers that you read, generally the first thing you'll see is a descriptive statistics table, mean, standard deviations, frequencies, etc. You need that so that we can replicate our findings so other researchers can do the same thing. Replication is key in research. Just here's a little note, statistics, and I notice how I color coded these. So statistics is the sample, right? So this is what we measure, right? Statistics is the sample as parameters are population. So we use statistics to estimate population parameters. So like there's a population mean, the fixed value, but that there's also statistics. Those are gathered from samples so that we can estimate the population parameters. This whole idea of replications of findings. I was reading some of your comments about research and, the role of research. And most of us assume that research is so, I don't know, meaningful when we read a study. Wow, this tells us everything. It tells us nothing, to be honest. It's just one of many possible findings from a virtually infinite number of samples. I mean, it's just crazy, how many samples we can have and how many findings we could have. We want them to be the same if possible, so we can have consistency, but that doesn't always occur. Location and spread and statistics. These are two types of statistics we look at. One is for location, we look at things like the sample mean, the median, the mode. Those are all different measures of location. So the mean, if you're not familiar with this, essentially it's the center point of a distribution. If it's perfectly normally distributed, it looks like a bell curve. It would be right in the center. And in that case, the mean, the mode, which is the most frequent value, and the median, the middle value, would all be the same. This is how we calculate the mean, just in case you want to know. Our sample variance is just shows us this is a measure of spread, and usually we'd use the variance when we're dealing with normally distributed variables. Or at least this measure of the variance here. There's other ways to look at spread. And here we have like a sum of squares in the numerator divided by n minus 1. Again, there's just a lot of stuff here that is not crucial, but it's important to note why we square this numerator, because if we didn't, we'd have like a value of 0 for the sum up here. So we square it. So it's a sum of square differences. If you're interested, I can show you that these measures, the sample mean and the sample variance, are unbiased estimates of the population, of their population counterparts. So again, remember they're estimating population parameters. There's a population mean and a population standard deviation somewhere. But I show you these derivations here, other YouTube videos, and I mentioned that already. Standard deviation is something that we use very frequently in statistics, and you'll see, in fact, people generally report the mean and the standard deviation. That's just the square root of the variance, but it removes the units, so it's unitless, and it makes it easy to make comparisons. Here's an example of a distribution. We'll talk a lot about distributions. Generally, we like to focus on the normal distribution because that's the most common and the easiest, and so lots of interesting things about the normal distribution. But a distribution is just a distribution of sample size, well, of numbers per level of some variable. So here's a variable. This is its, if you think about it, this is its sample space. So the sample space for a variable, this is, for instance, a smoking status, like you did not smoke in the past 30 days, smoked in the past 30 days, smokes weekly. So it's just a variable. And this is the distribution. It's how many individuals fall in each of these categories. And we can also write those as percentages. Of course, the percentage has to add up to 100% because it counts for everybody. I already mentioned what the mode and the median was. Often we calculate the median. It tends to be used more when our variable is not normally distributed. We could report it anyway, but it works better. So the mean works when we have a normal distribution. The median is useful when we don't. And I show you how to calculate the median if you're interested in that. It's the middle value here. And again, I show this isn't something you have to do, but if you're interested in it, why not? We often report the interquartile range. That's the middle 50% of a distribution. One of the reasons, again, as a measure of spread in lieu of, say, a variance, or in conjunction with a variance. One reason we do that is because it eliminates the impact of outliers. Outliers are extreme cases. Sometimes you get extreme cases because, well, there are extremes in everything. Like for measuring weight, there could be somebody who's morbidly obese or who is very, very skinny. So those people are outliers. However, we can also have outliers due to data entry errors. And I show you how to calculate the interquartile range if you're interested. Again, it's just the middle 50% of the distribution. And one more thing here, quantiles, they break a distribution into equal parts. There's many different types of quantiles. There's deciles, breaks the distribution into 10 equal parts. There's quintiles, breaks the distribution into 5 equal parts. There's quartiles, breaks the distribution into 4 equal parts. So there's many different types of quantiles. Anyway, that's just a start and just to wet your whistle to get you ready for the rest of what's to come. All right, thank you.